I'm from Oxford Technical Solutions, and we design and manufacture inertial navigation systems. So these are products that combine GNSS and IMU technology to measure very accurate position and motion and dynamic information. So these are used for things like vehicle dynamic testing, ride and handling, stability control, as well as in the verification and validation of ADAS systems for things like relative measurements, car to lane, these types of measurements that need provide a reference to validate the onboard systems for. Sure, so GPS is probably the most commonly known term. That is specifically the US-based constellation, satellite constellation. More and more nowadays you'll hear the term GNSS, which is a more umbrella term for the global navigation satellite systems. So that covers GPS, which is the US system, GLONASS, which is Russian owned, Galileo, which is European, and Beidou, which is the Chinese system. And all of these satellite systems have global coverage and provide positioning information based on where the satellites are and where your receiver can see. Some of the developments over the recent years have been in the commoditization of this technology, so making it much more affordable, smaller, cheaper, easier to get hold of. And in particular, there's a technology called RTK, stands for real-time kinematic, which is a process of analyzing the signals from GNSS and combining it with correction data from a base station. And this essentially allows you to achieve centimeter level position accuracy through these satellite signals. And that has become much more prevalent in recent years, which has allowed very high accuracy systems to be more widely available and come down in cost as well. So in our products, all of our current generation products are capable of tracking all four of the main constellations. So they are quad constellation, so that includes the GPS, GLONASS, Galileo, and Beidou. So that ensures we get global coverage for our customers all over the world, no matter where they are. They're going to get a good number of satellites for their testing and high accuracy systems. So one of the drawbacks, the primary drawback of GNSS-based technology is you need to have line of sight visibility to the satellites to receive the signals. So on proven ground environments, that's generally fine. If you have a nice open space with good visibility, you can maintain your good accuracy there. But we're seeing more and more testing start to take place on the open road to test the vehicles in these real-world environments and scenarios. And in those kinds of environments, you can have things like tree cover or bridges, tunnels, tall buildings that can obstruct the satellite signals. And in those cases, if you were relying on GNSS alone, your position accuracy would worsen, you would lose your position for the vehicle, and that data wouldn't be usable. So with our systems, because we have the combination and the sensor fusion with the IMU technology, the inertial technology, we're able to fill in those gaps when GNSS isn't available. We also have tight coupling technology we call GXIX, which again helps in those more difficult environments where there's reflections from buildings, or maybe you can only see one or two satellites at a time. We're still able to use that information. And then also, one of our big focuses at the moment is looking at completely GNSS denied environments and how we can expand our operational abilities to those kind of environments. So, for example, we've done some work with Hariba Myra in the UK and other test houses around the world who are looking to do indoor automotive testing for things like controlled weather conditions, low light testing, and so we've seen these kind of purpose-built facilities like covered areas for that control, or in the case of Hariba Myra in the UK, they built a multi-story car park, a purpose-built car park, to do automated valet parking testing. So in those kinds of environments where you're in an indoor scenario or a covered area where the GNSS signals are completely blocked. We need some other form of position reference in order to maintain that level of accuracy. So we've done integrations with systems such as ultra-wideband, working with POSIX, our partner there, to provide an indoor positioning solution using ultra-wideband, which kind of mimics the same kind of technology as what you would use with satellites to calculate positioning, but on a much more local scale, with anchors that you can set up around your infrastructure. So we do a lot of work with pretty much all global OEM vehicle manufacturers, tier ones and test houses on the test and validation side, who use our equipment as a reference for their validation and testing. We have also recently been working on products that are more designed to be integrated into vehicles, particularly for autonomous vehicles that are being developed, where again they need a source of positioning information and localization for their guidance and control algorithms, essentially, so they can know where they're going when they're driving themselves. So we've been able to develop our technology, make it much more scalable, make it much easier to integrate with these kinds of vehicles. I think so. The role of autonomous vehicles, I think, will play a bigger role in sustainability in terms of improving fuel efficiency and just general traffic conditions, and improving the reduction in emissions, again related to electrification, is very intertwined with automated vehicles as well. So all of these new developments in looking at reducing emissions and increasing sustainability, they're all going to need some form of testing and validation on that side, and then also in the control and guidance for the autonomous vehicles, we can play a role there as well. I think the future of ADAS in India is based on the presentations we've had at this event recently. There's lots of work and development going on there, and there's clearly a lot of drive for the Indian community to adopt these technologies. I think culturally there's a challenge in terms of the kind of, it's a very unique driving culture here in India, and the ADAS technologies are definitely going to have to be tailored for the types of roads and the behaviours for drivers here. But I think it's definitely will be interesting to see it develop.